Good morning guys, and welcome to today's video on the Fibonacci sequence. Right guys, this video was recorded on Wednesday the 22nd of July 2020. Right guys, if you're new, welcome. My name is Abdallah W, and I'm a private maths tutor and a recently qualified maths teacher for secondary and primary. I make videos on Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths and further maths as well as some undergraduate degree level maths. Okay, please do subscribe to my channel, and drop it a like, and also turn on post notifications by pressing the bell icon so you guys can be notified of when my uploads are. Okay, but let's get on with today's video, guys. Okay, so we're going to be looking at Fibonacci sequence today. Okay, right guys, these are our object today's lesson. Okay, so to understand the Fibonacci sequence, to understand the term rule actually for that, and then to know the difference between a geometric sequence and an arithmetic sequence. Okay, so we're looking at grade 4, 5, and possibly I want to say 6 year, but it's probably mainly grade 4, 5 actually. So it's the top end of foundation, lower end of higher. Okay, right guys, okay, so today's lesson, so we're going to be looking at Fibonacci sequence. Okay, so this is my Fibonacci sequence actually. So I've got 1, 1, 2, 3, 5. Okay, so a few key points to remember, guys. Okay, so a sequence no matter what type of sequence it actually is, so a sequence can never start from the term 0. Okay, so a sequence can never start from like 0 essentially. Okay, so 0 can never be the first term. However, it can be a term within the sequence. Okay, but it cannot be the first term of any sequence, whether it's a geometric, a arithmetic, a quadratic, a cubic sequence, a Fibonacci, Fibonacci sequence, or geometry, if I said that actually, so it can't be any, but 0 can lie as part of a sequence, so it can be the second, third, fourth, fifth, or sixth, or whatever many terms. It just can never be the first term of a sequence. Okay, so that's like a little rule. Okay, right. Secondly, guys, right, okay, we're gonna come on to the rule actually in a second. Okay, so 1 to 1, okay, I'm adding 0. Okay, 1 to 2, I'm adding 1. Okay, 2 to 3, I'm adding 1. And then 3 to 5, I'm adding 2. Okay, so straight away, we know that this is not an arithmetic sequence because it is going up at different amounts each time. Okay, but the rule here, guys, is to work out the next term, you add the previous two terms together. Okay, so you are given 1 and 1. This term is worked out by doing 1 plus 1, which is the previous two terms. The next one is worked out by doing 1 plus 2. Okay, so you look at the so the previous two terms before that number. Okay, so you add on the previous two terms each time. Now you could argue essentially, you could actually argue that there's like a 0 there because obviously 0 plus 1 makes 1 actually. But for argument's sake here, obviously for what I said, it's just naturally just obviously start the sequence obviously from 1 rather than that. Okay, so you will always be given actually obviously the first two terms. Okay, obviously otherwise they can't obviously ask you to obviously work it out unless you are given the first two terms of a sequence, and then asked to obviously follow it up, obviously the next few terms, unless you were given the appropriate or the necessary information. Okay, right guys, next slide actually. Okay, so example 1 actually, so Fibonacci sequence. Okay, so 1 1 2 3. Okay, right, the question is asking for the next 3 terms of my sequence. Okay, right. So to work out the next one, so it will be, okay, so 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. Okay, so next one, and the next one's going to be 3 plus 5, which is 8, and the next one's going to be 5 plus 8, which is 13. Okay, so again, a bit of mental arithmetic there. Just obviously get your addition, obviously engaged and practiced. Okay, so the next 3 terms are 5, 8, and 13. Okay, which are what I put there. Okay, Right, guys, example 2 actually. So again, Fibonacci sequence. Okay, right, 1, 1, 2, 3. Okay, so we're asked to work out the 30th term here. Okay, now here we could actually argue actually that you might be thinking, okay, well, how do I work out like the term rule actually? Now this one's a bit more trickier, okay, because I know that it's not a quadratic actually because yeah, because you can't have a two terms that is the same number and still be actually quadratic actually, yeah, so it's not actually possible. It may be a cubic here or a quartic, I'm not sure actually. So it might be worth actually, obviously you guys doing a bit of investigating actually and give it a go. I tried it yesterday like on like a paper form actually. I tried to work out like a general sequence and I actually got stuck actually because I got to like the 4th or 5th difference and I couldn't spot like a genuine pattern, okay, like in terms of like converting it to algebra, okay. It is not a quadratic here for definite, okay, but it may be possibly mixed a cubic, yeah, like a cubic mixed with maybe like a geometric part, yeah, or like that, or it might be like a geometric sequence or series, yeah, depending on how you look at it, yeah. But obviously, if you're interested, guys, yeah, obviously feel free, yeah, to obviously take a research. Yeah, take a look actually. There's a website that I found actually called, like, I think it's called www.mathsisfun.co.uk or .com, I think, yeah. So that's quite a good website for like, yeah, for like general research. Okay, yeah, but yeah, sorry, I was sidetracking a bit there. So we are asked to work out the 30th term. Okay, so look at it. Obviously, I actually worked out the Fibonacci sequence case for the first 30 terms. Okay, so first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, 23rd term, 24th, 25th, 26th, 27th, 28th, 29th, 30th. So the 30th term is 832,040. Okay? So that is my answer for that, guys. Okay, so I worked it out. Obviously, yeah, the long way for that. Okay, now obviously going back on my point earlier, actually, yeah. So there might be like an algebraic way actually. So yeah, that is something, yeah. I'm not too sure about actually very well actually. But obviously, if you are, yeah, aware of like a formula or like a, yeah, like an nth term, yeah, obviously feel free, yeah, to comment below. Yeah, obviously, yeah. I would like to obviously, yeah, hear your guys' thoughts on this. Okay, right, guys. Example 3, Fibonacci sequence. Okay, so let's say I've got the sequence A plus B, and then A plus 2B. Okay, so this time, okay, work out the next term actually. So it's Fibonacci. So this is actually the algebraic form actually. So obviously we've got the first term, okay, which is essentially 1, okay, yeah, and then you've got another number, okay, which I've called B, okay, so then A plus B, yeah, obviously, so it would follow this, okay, so yeah, it follows this pattern. So to work out this next term is B plus A, which is, or A plus B, okay, and then the next term would be B plus A plus B, which is A plus 2B. Okay, so yeah, so it follows this kind of pattern, okay, so it follows that actually. So the next term is A plus B, okay, plus A plus 2B. So it's going to be 2A plus 3B. Okay, so that is the next term. So 2A plus 3B. Right, guys, part B says, given that the third term is equal to 6 and the fourth term is equal to 15, find the value of A and B. Okay, so the third term is this term here. So that's so that's the third term, and then that's the fourth term, guys. Okay, so we are told that A, oh, it looks like a 9 there, sorry. A plus B is equal to 6, and then we're told that 2A plus 3B is equal to 15. So we've now got a pair of simultaneous equations that we can solve. Okay, so what I'm going to do is do equation 1 times 3. So I get, so we're going to move it here. So I get 3A plus 3B is equal to 18. And then the second equation is going to stay the same. Okay, sorry about my handwriting, guys. Apologies. Okay, plus 3b is equal to 15. Okay, I'm going to do this equation minus this equation, so we're going to subtract equations. 3a minus 2a gives me a, 3b minus b is going to be 0, 18 minus 15 gives me 3, so a is equal to 3. And then I can sub a equals 3 into here. A plus b is 6, 3 plus b is 6, therefore b has to equal 3, okay? So they would be your numerical solutions to that question, okay? So that would give you the numerical solution for that question, okay? Yeah. So if you're actually interested, yeah, so if you're interested, so A plus B actually would give you 6 here, which is correct because it's that. And the next one you can sub it in 3 plus 2 times 3 gives us 15. Okay, 3 times so sorry, 2 times 3 is 6, plus 3 times 3 is 9. 6 plus 9 gives you 15 actually, which is correct. Okay, so that's like a quick way to like check your answer, yeah, as part of that, okay? Yeah, so I hope that actually made sense, guys. So that is the algebraic, yeah, like obviously version, yeah, of the Fibonacci sequence that I've put in there, okay? Right, arithmetic sequences, guys. Okay, so arithmetic sequences are where the term-to-term rule is fixed by adding or subtracting the same amount. Okay, so here are a list of arithmetic sequences: 2, 4, 6, 8. So this one, I am adding 2 each time. Okay, this one, 1, 5, 7, 8, and 9, I'm adding 2 again. Okay, this one, 10, 9, 8, 7, 6, I'm minusing 1 each time. This one, I'm adding 6 each time. Okay, so I am adding or subtracting the same amount each time. Okay, so these are what I call arithmetic sequences. Okay. Right, guys. Okay, so geometric sequence actually here. So it's multiplied by a fixed number. Okay, so multiplied by a number. Okay, so multiplied by either a whole number or a fraction. Okay, so this is I'm multiplying this by 2. Oh, it looks like an add there. It should be a multiply. Okay. I really ought to get a mouse actually because it is a bit difficult doing this on the keyboard actually. Okay, 3 times 3 is 9, so 9 times 3 is 27, sometimes by 3 each time. Minus 6 to 12, it'll be minus 2, sometimes by minus 2 each time. Okay, yeah. Like that, okay, and I can have a sequence here where I multiply by a half, a third, a quarter, so they would all still be classed as geometric sequence. So you multiply either by a whole number, okay, so I'll just call it A, or you multiply by a number, obviously, 1 over A, okay, obviously, provided that A isn't 0, okay, because we cannot, obviously, we cannot do, 1 divided by 0, okay, for that, okay. So I hope that makes sense, guys. Okay, any questions? Obviously, comment below. In the comment section. Okay, right, guys. Pause the video. Okay, and try these questions. Okay, and then press play once you've finished, guys. Okay, guys. Right here are my answers. Okay. So mark your work, and guys, feel free to obviously comment below like what you got out of 5. It would be interesting to see, and like in South last year because it will provide me with some sort of feedback on these like video lessons. Okay, okay, so let me know actually. Otherwise, don't worry about it. If you're not comfortable, okay. Right, guys, end the lesson. Okay, so thank you so much for watching. I really do appreciate it. Please do subscribe to my channel. Drop the video a like. Enable notifications by pressing the bell icon. And obviously share my videos around actually. Comment below. Any questions or queries that you might have. And feel free to just like pass it around like with like friends. Or like family. That actually might find this useful. Okay. For this, okay, so stay safe, enjoy summer safely, okay, And then the next few lessons we're gonna be looking at Venn diagrams. So hopefully on Friday's lesson. So we're gonna do like a 3-part like lesson for like Venn diagrams, because there's quite a bit to cover for like Venn diagrams. Okay, so I hope that was okay, guys. I hope it was useful. Okay, thank you so much for watching. Stay safe, and I will see you soon. Okay, happy Wednesday. Bye now.